Good morning, I'm Rick Collins. Today we're here to talk about thread identification. In order to successfully identify a thread, you must first determine whether it's a port thread or a tube thread. It's actually easy to do. To determine whether you have a port thread or a tube thread, you must first know where the fitting is going. So for example, port threads, here's a cylinder with an NPT port, a valve with a SAE port, a manifold with BSPP ports, and even a pump with an SAE port. Really easy. There are two different types of sealing methods. There could be a parallel and there can be a taper. A parallel thread requires some type of a soft seal. For example, an O-ring, the O-ring in the SAE. The threads in a parallel thread serve one purpose, and that's to hold the fitting in place. You always have to have a soft seal with a parallel thread. Now, on the other hand, a tapered thread, an NPT or a BSPT taper, the threads serve two purposes. Purpose one would be to hold the fitting in place, but the secondary purpose would be to actually form the seal. The threads are made to distort when they're threaded into the port, and a tapered thread always requires some type of sealant, and that sealant could be a Teflon tape, or it could be some type of paste or a liquid pipe sealant. Now let's talk about tube threads. Tube threads, unlike port threads, almost always swivel. You'll find tube threads on the end of a hose. In this case, we have a seal lock or O-ring face seal, a JIC. Tube threads also go on the end of a tube assembly, or on potentially pipe. Several common examples of a tube thread would be JIC, seal lock or O-ring face seal, or a DIN metric. So to make it easy, the tip is tube threads almost always swivel, and tube threads, if you can flare it, flange it, crimp it, or fix a ferrule to it, it's a tube thread. Thanks for your time today. And on our next session of Shop Talk, we're going to talk about the details of thread pitch and thread diameter. Look forward to it.